Before we talk about the standard equation of an ellipse, let me develop some motivation for it. So let's suppose you have a circle with center 0, 0. And radius r. Then we could write the standard form of the equation as x squared plus y squared equals just r squared, right? Becomes pretty simple looking when the center is 0, 0. There's another form of this equation that's commonly used. If you divided both sides by r squared to get 1 on the right side, so divide everything by r squared to get 1 on the right side, then you have x squared divided by r squared plus y squared divided by r squared equals 1. And that's actually the standard form of the equation of an ellipse, a circular ellipse. Circles are ellipses, but ellipses aren't necessarily circles. Now, what do you think would happen if we replace this r squared with something just a little bit bigger, or maybe a lot bigger? Well, it would stretch out the circle in the x direction and create an oval shape instead of a circular shape. An ellipse is an oval-shaped curve. To illustrate that an ellipse is just a warped circle, let's start with a circle, say radius 2, center 0, 0. And I've graphed that here on Desmos for you. X squared divided by 4 plus y squared divided by 4 equals 1. So that's in the form I was just talking about, where you divide by r squared. In this case 4, so the radius of the circle is 2. And you can see that's exactly what you get. You get a circle centered at 0, 0, radius 2. So there's an x-intercept of 2, 0, an x-intercept of negative 2, 0. What happens if we change the denominator on the x squared to, say, 9? Then the circle gets warped into an oval shape, and it's warped horizontally. This x-intercept is now at 3, 0, and this x-intercept is now at negative 3, 0. So what's going on here? Well, look, if you take a look at the denominator of x squared, it's 9. And now this point's at a horizontal distance of 3 from the origin, so is this point. Oh, so it looks like maybe the denominator of x squared gives you the distance from the center. I said the origin a minute ago, but the origin is the center of this thing. It looks like that denominator of x squared, if you take the square root of it, gives you the distance from the center of the ellipse on out to the edge of the ellipse, to the curve, in other words, horizontally. And likewise, so let's do the same thing with y. Let's change it back to a circle of radius 2 and change the y to, say, I don't know, 16. The number underneath y squared, that is, to 16. And then look at what happens here. We've got a circle that's then been stretched out vertically. Whoops. It's been stretched out vertically, and this intercept here that was at 0, 2 is now at 0, 4. This intercept here, which was at 0, negative 2, is now at 0, negative 4. So it looks like if you take the square root of the number underneath the y squared, in this case 16, that gives you the vertical distance that you have to go from the center of the ellipse to get to the curve that is the ellipse itself. So, and by the way, if you change like the number underneath, say, y squared to, say, 2, instead of being stretched out in the y direction, it gets smushed in the y direction. It gets compressed in the y direction. But look, that intercept now has a y-coordinate of 1.41, which is approximately the square root of 2. In general, then, if you want to talk about the standard equation of an ellipse, we don't call those two denominators r anymore because they're not necessarily the same. So the standard equation of an ellipse centered at 0, 0 would look like this. X squared over, let's say, a squared plus y squared over b squared equals 1. Now this is with center HK. C for center. Not HK, sorry, 0, 0. You'll talk about center HK in your next class if you take college algebra. Now, there's actually two standard forms because we usually insist that A is the bigger number. So if it turned out that the number underneath y squared was bigger, then we would switch the a and the b, but we're not going to worry about that here because that doesn't affect how you graph it. So we're just going to take this guy as our standard equation. Let's graph this ellipse. X squared divided by 9 plus y squared over 25 equals 1. First of all, I want you to recognize what this is going to graph to be before you graph it. It's going to be an ellipse. Why? How do you know it's going to be an ellipse? It's in that standard form. It's in the form x squared over a squared plus, it's very important, that's a plus right there, y squared over b squared equals 1. Any equation that's in that form is going to be an ellipse. Now, okay, there's a technicality here. In a more advanced class, you're actually going to call the 25 a squared and not b squared. But for graphing it, it doesn't matter. And I'll show you why. Okay, so you technically have two standard equations for an ellipse. You'll learn all about that in your next class. We're not going to worry about it here. All you need to know to graph this thing is, first of all, okay, if you don't see that you're subtracting anything from x inside a set of parentheses, what's h? The first quarter of the center is 0. And then same thing, k is 0. So if you just see x squared and just see y squared, the center is 0, 0. Okay, so from the center, you don't even need to plot it, it's right there. From the center, you have to figure out, okay, how far left and right do I go to get to the curve that is the ellipse? Well, all you have to do to figure out how far left and right you go is you just take the square root of the number underneath the x squared. That's all you need to do. And so what's the square root of 9? It's 3. So you don't even have to think in terms of a or b squared. You just think the square root of 9 is 3. So I'm going to go left, right, 3. The square root of the number underneath the x squared. From the center, go left, right, 3. So 1, 2, 3. 1, 2, 3. And then, well, up, down, what do you think? You're going to go the square root of 25, the number underneath y squared. Now, why is that easy to remember? Y controls the vertical, right? You go up and down, vertically in other words, the square root of the number underneath y squared. Y controls the vertical. You go left and right, the square root of 9, which is 3. Oh, that 9 is underneath x squared technically, and x controls the horizontal, doesn't it? That's why it's easy to remember. And that's why it's no harder than graphing a circle. So you're going to go left and right, the square root of this number, up and down, the square root of this number. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And so this ellipse, this oval shape is a stretched out circle vertically, isn't it? And so how do you draw it? Just do your best. Make it, don't make anything sharp. Everything should be a nice smooth curve when you graph it. So the tendency is to kind of make this sharp right there. Don't do that. Make it come in nice and smooth and rounded at the where it hits the point. And it doesn't even have to look this good. And I'm not saying this looks good, but it doesn't even have to be that good. As long as I can tell you're meaning to draw a kind of egg shape and an oval shape, you're good.